Every day, the 30 employees at an auto plant each have probability 0.03 of having one accident and 0 probability of having more than one accident. So you could either have one accident or no accident. Given there was an accident, the probability of it being major is 0.01. All other accidents are minor. The numbers and severities of employee accidents are independent. Let X and Y represent the numbers of major accidents and minor accidents respectively occurring in the plant today. Determine the joint moment generating function MXY ST. So with this notation, the S corresponds to the X and the T corresponds to the Y. So there are three possible outcomes. Either there will be a major accident, minor accident, or no accident. So major accident, since probability of accident is 0.03, and if an accident happens, then the probability of it being major is 0.01. So probability of major accident would be probability of accident times probability of that accident being major. So 0.03 is the accident and 0.01 is the probability of that accident being major. So you get 0.0003 as the probability of a major accident, and probability of a minor accident would be probability of accident times probability of that accident being minor. So if the probability of an accident being major is 0.01, then the probability of it being minor will be 1 minus 0.01, which is 0.99. So probability of an accident being minor would end up being 0.0297. And so this is a multinomial distribution with n equals 30 because there are three possibilities. Actually, it's a trinomial distribution. You could have major accident, minor accident, or no accident. And so you can call it multinomial or trinomial in particular. N is 30 because there are 30 employees. P1 is the probability corresponding to the X, the major accident, which is this. P2 is this for the minor accident. And we know that in this particular case, but this particular case will mean in case of multinomial distribution, we know that let's just say MGF for a trinomial distribution. Okay. So it would be P1 e power s plus P2 e power t. Remember, we want the moment generating function corresponding to the major accident and minor accident. X was the number of major accidents, Y was the number of minor accidents. That's given in the problem. And so the S is corresponding to the major accident. So that's why I've written P1 with the e power s. And I've written P2 with the e power t because t was corresponding to minor accidents, and P2 here is the probability of minor accident, which is 0.0297. And then the third probability would be 1 minus P1 minus P2, and that doesn't have an e with it because the third probability was of no accidents. And they asked us to write the moment generating function of involving the major and the minor accidents. So that's why for the no accident, we don't have any exponential factor. So it's only the ones, the variables that you see here for which you need the MGF. You would have an exponential factor corresponding to each of them multiplying with their probability and everything added up. The whole thing to power n. So P1 is 0.0003. P2 is 0.0297. And so this time e power s, e power t, and the 1 minus P1 minus P2 ends up being 0.97. And the n is 30. So we get this one, and that is choice B.